Krebs cycle. We call this as the citric acid or TCA cycle. So we start from the pyruvic acid, which is of 3 carbon from the end of the glycolysis. On reaction with acetyl coenzyme A. It enters into the mitochondria, that is on reaction with oxaloacetic acid and of acetyl coenzyme. Coenzyme sleeps and it forms the citric acid, which is of 6 carbon. Then in presence of enzyme aconitase, it forms cis aconitic acid, which is again of 6 carbon. Again in presence of aconitase, a water molecule is added. Here water molecule is released and it forms citric acid, which is again of 6 carbon. Then a NAD molecule and a positive on reduction form NADH plus H positive, and the enzyme is isocitric dehydrogenase. It forms the oxalosuccinic acid, which is again of 6 carbon. Then in presence of enzyme oxalosuccinic decarboxylase, it forms alpha keto glutaric acid, which is of 5 carbon. Then again it releases NAD positive, NADH plus H positive with coenzyme A, and enzyme ketoglutaric dehydrogenase. It forms the succinyl coenzyme A, which is of 4 carbon and releases CO2. And then the coenzyme is released, a water molecule is added. Here ADP plus GTP, ADP forms the ATP plus GDP, GDP to ADP. Then it forms the succinic acid, which is of 4 carbon. Then a FAD molecules In presence of enzyme succinic dehydrogenase, forms the fumaric acid of 4 carbon. Then presence of enzyme fumarase, it forms the malic acid which is of 4 carbon. Then this malic acid, NAD positive is converted to NADH plus H positive in presence of enzyme malic dehydrogenase and forms the oxaloacetic acid. And again in presence of water molecules, it will on reaction with acetyl coenzyme, it forms the citric acid. This is the Krebs cycle. So Krebs cycle or tricarboxylic acid cycle this cycle has been named after the German biologist, biochemist Sir Hans Krebs from England. You can say in England, who discovered it in the 1937. He won Nobel Prize for this work he got the Nobel Prize in 1953. Krebs cycle is also called the citric acid cycle after one of the participating compounds. We call this as the citric acid cycle also, and it takes place in the mitochondrial matrix. It takes place in mitochondrial matrix. Krebs cycle consists of 8 cyclic steps. Each step is catalyzed by a specific enzyme. So in Krebs cycle, the entrant molecule is 2 carbon acetyl coenzyme and the receptor molecule is 4 carbon. So entrant molecule is 2 carbon. We call it as the acetyl coenzyme. And other is the receptor is the 4 carbon, that is oxaloacetate. Then is the condensation. Acetyl coenzyme A reacts in the presence of water with the oxaloacetate normally present in the cell, forming 6 carbon citrate and freeing coenzyme A for use in pyruvate oxidation. The high energy bond of acetyl coenzyme A provides energy for this reaction, and this reaction is catalyzed by citrate citrate synthetase enzyme. The citrate has 3 carboxyl group. The citrate has three carboxyl groups. Hence, Krebs cycle is also called tricarboxylic acid cycle or TCA cycle after its first product. So oxaloacetate plus acetyl. So oxaloacetate plus acetyl coenzyme A plus water gives you, in presence of citrate synthetase, gives you citrate plus coenzyme A to be reused. Reorganization, that is dehydration, so isocitrate gives off a pair of hydrogen atoms, oxidation, and a molecule of CO2 decarboxylation and becomes 5-carbon alpha ketoglutarate. The pair of hydrogen atoms give 2 electrons and 1 hydrogen to NAD, forming NADH plus H positive. The enzyme isocitrate dehydrogenase catalyzes the reaction in the presence of manganese 2 positive. NADH generates ATP by transferring its electrons over the ETS, electron transport system. So isocitrate plus NAD positive, isocitrate dehydrogenase in presence of manganese 2 positive gives you alpha ketoglutarate plus NADH plus CO2 plus H positive. Then is oxidative decarboxylation. So this is a second stage process. In stage 1, two-stage process it is. Stage 1, coenzyme A reacts with alpha ketoglutarate, forming 4-carbon succinyl coenzyme A and releasing CO2 and a pair of hydrogen atoms. The reaction is catalyzed by alpha ketoglutarate dehydrogenase complex enzyme. The pair of hydrogen atoms pass 2 electrons and 1 H positive to NAD positive and forming NADH plus H positive. So alpha ketoglutarate plus coenzyme A plus NAD positive gives you alpha ketoglutarate dehydrogenase succinyl coenzyme A plus CO2 plus DH plus H positive. In stage 2, succinyl coenzyme A splits into 4-carbon succinate and coenzyme A with the addition of water. The coenzyme A transfers its high energy to a phosphate group that joins GDP, guanosine diphosphate, forming GTP, guanosine triphosphate. The latter is an energy carrier like ATP. This is the only high energy phosphate produced in the Krebs cycle. The stage 2 reaction is catalyzed by succinyl coenzyme A synthetase enzyme. So succinyl coenzyme A plus H2O plus GDP to ADP. Succinyl coenzyme A synthetase gives you succinate plus coenzyme A plus GTP plus ATP. In a plant cell, this reaction produces ATP from ADP. So in plant cell, so ATP from ADP. Oxygen to oxidize a carbon atom to CO2 is taken in step 4 and 5 from a water molecule. Sixth is the dehydrogenation. This process converts succinate into 4-carbon fumarate with the aid of an enzyme succinate dehydrogenase and liberate a pair of hydrogen atoms. The latter pass to FAD, flavin adenine dinucleotide, forming FADH2. Hydrogen is carried by FAD in the form of whole atoms. So succinate plus FAD in presence of succinate dehydrogenase forms fumarate plus FADH2. Hydration. So this process changes fumarate into 4-carbon malate in the presence of water and an enzyme fumarase. So fumarate plus water gives you in presence of fumarase gives you malate. Then 8th step is the dehydrogenation. This process restores oxaloacetate by removing a pair of hydrogen atoms from malate with the help of enzyme malate dehydrogenase. The pair of hydrogen atoms pass 2 electrons and 1 H positive to NAD, forming NADH plus H positive. So malate plus NAD positive gives you maltate dehydrogenase in presence of enzyme. So it gives you oxaloacetate plus NADH plus H positive. So oxaloacetate combines with coenzyme A to form citrate, and so the cycle continues.